And this is how a typical simple neural network looks like. So if I were to show you how this works, if we were to step through this, think of what is happening here. I have neuron 1, this is 2, and this is 3. And mind you, this neuron is basically input times weight, sum it up, add the bias, and put it through an activation function. Okay, each of these neurons are these pieces of computation. Now I have 3 neurons here. I provide I1, I2, and I3 to the first neuron, and then there's an output that comes here. I put I1, I2, and I3 in the second neuron, and out comes an output here. I put I1, I2, and I3 here, and out comes the output of the third neuron. Okay, and I can have as many neurons as I please. I can have m number of neurons here, so I'll have m outputs here. So I can have as many neurons as possible here. Okay, there's nothing that is going to stop me on choosing the number of neurons that I want to put here. So basically, whenever an input comes in, it goes into a neuron and an output comes out. Each neuron is actually the multiplicative sum of inputs and weights. We add some bias and then we put it through an activation function. And then out comes the output of one neuron. A combination of many such neurons is what orchestrates a neural network. Okay, so it's basically a network of these neurons, hence the name neural network. Okay, now this is what we call the input layer, and this is what we call the output layer. Again, this is simpler than the simplest neural network that we'll ever see, but usually real life examples are not so simple, right? So we'll have to introduce some complexity here. We'll do that right here. So what I've done here is I have these inputs still with me, and they are going through neurons. Each and every one of these inputs is going through each and one of these neurons. The output of these neurons in turn is going as the input to a bunch of other neurons. Okay, so the output of these first set of neurons is going as an input to a next set of neurons, and then on the other side we finally get a set of output. So what do I call this now? I have the input layer there, I have the output layer there. This I know, right? Because I've seen what a simple neural network architecture looks like. This layer in between that we are seeing will be called a hidden layer. Okay, so again, the more hidden layers you have in your neural network, the deeper the network is. I'll just write it out so that it's perfectly clear. Okay, so more the number of hidden layers, deeper the network. Okay, so again, just take a step back and think, what is a neuron? A neuron is basically a box of computation. What is inside this box? I'm basically taking in some input, multiplying it by weights, adding some bias, summing it up, putting it through an activation function, and out comes an output. Each one of these neurons represents that box of computation that we just discussed. Now the output of this layer of neurons can be passed as input to the next layer of neurons, and this starts getting called a hidden layer. And this is basically the motive here. The more the number of hidden layers, the deeper the network is, the more complicated the network is.